Hi students, today we are going to discuss exercise 6.1 and 7th problem. Prove by vector method that the parallelograms on the same base and between the same parallel are equal in area. What is given? The parallelogram, the same base and between the same parallels are equal in area. That is a two parallelogram. Is the same base and the same parallel lines. The one of the area of the parallelogram equal to another parallelogram. The area of the another parallelogram. You have to prove the result is area of the one of the parallelogram equal to area of the another parallelogram. What is given? The parallelogram is the same base and are parallel lines. Let A, B, C, D be the one of the parallelogram. Let A, B, C, D be the one of the parallelogram. And next one, A, B, C dash, D dash be the another parallelogram. Please, A, B, C dash. This C dash and D dash be the another parallelogram. The point is D dash. First one A, B, C, D be the one of the parallelogram. And another one parallelogram is A, B, C dash, D dash be the another parallelogram. The same base and the same parallel lines. You have to prove the result. The area parallelogram A, B, C, D equal to area parallelogram A, B, C dash, D dash. You have to prove the result. Area of the parallelogram A, B, C, D equal to A, B, C dash, D dash of the area parallelogram. Given, let A, B, C, D be a parallelogram and A, B, C dash, D dash be the another parallelogram and the same base parallelogram, same base AB and the parallel CD and the parallel CD. We have to find first one the area parallelogram A, B, C, D. First one the area parallelogram. The area of parallelogram A, B, C, D equal to first one the area parallelogram A, B, C, D equal to area parallelogram is base and height. That is the adjacent side is AB into AD. The area parallelogram is AB into AD. That is a modulus AB vector cross AD vector. That is the area of parallelogram. ABCD is AB vector cross AD vector. Adjacent sides. Now we can write AB vector into AD vector is. Now we write in AD vector equal to AD vector is A D dash vector plus D dash D vector. Now write in AD vector is A D dash vector plus D dash D vector. That is AD vector is A first one A D dash vector plus D dash D vector. Now write in a AD vector. This bracket. Now multiply AB vector into A D dash vector plus AB vector into D dash D vector. Now multiply AB vector on these two terms. The first one AB vector cross A D dash vector. First one plus next one AB vector cross D dash D vector. This is second one. That is equal. Next one modulus of AB vector cross A D dash vector plus AB vector D dash D vector is AB vector cross D dash D vector is AB vector and D dash D dash D vector are parallel. Two vectors are parallel. A B vector and D dash D vector are parallel. Two vectors are parallel. The vector product value is 0. Two vectors are parallel. That is AB vector and D dash D vector are parallel. The vector product of two vector values is 0. That is the value is 0. That is equal modulus of AB vector cross A D dash vector. That is the answer. AB cross A D dash is the first one. The area parallelogram is ABCD is AB into AD. Now getting the result is modulus of AB cross AD dash is now area of the parallelogram ABC dash D dash. C dash D dash. That is the result is the area parallelogram ABC dash D dash. That is the result is the area parallelogram ABCD equal to the area of the another parallelogram ABC dash D dash in series proof. Next problem, exercise 6.1 8th problem. If G is the center of triangle ABC, prove that area of triangle GAB equal to area of triangle GBC equal area of triangle GCA equal 1 by 3 times of area of triangle ABC. 1 by 3 times of area of triangle ABC. Given triangle ABC, the centroid, G is the centroid of triangle ABC, prove that this one equal to 1 by 3 times of area of triangle ABC. Now, draw the triangle. In triangle ABC, the vertices A, B, C. Let G be the centroid of the triangle ABC. That G is the centroid. Centroid means 3 medians are intersect at a point is G. That is the centroid. 3 medians. That is AD. That is the midpoint. Where D is the midpoint of the side BC. And where E is the midpoint of the side CA. Now join the line. That is P is the median, one of the median, and F is the midpoint of the side AB. Now join the CF. 3 medians intersect the point is G, where G is the centroid. G is the centroid of the triangle ABC. We have to prove the result. Area of triangle GAB. Area of triangle GAB. Area of triangle GAB equal area of triangle GBC. Area of triangle GBC equal area of triangle GCA. GCA equal 1 by 3 times of area of triangle ABC. We have to prove the first one, area of triangle GCA, GAB. First one GPA. And next one GBC, GBC, and third one triangle GAC equal to 1 by 3 times of the total triangle ABC. Let ABC be the triangle. Let ABC be a triangle, and the G be the centroid of the triangle. G be the centroid. The position vectors of first one, the position vectors. The position vectors of ABC is the position vectors OA vector equal. This OA vector. OA vector equal to small a vector. OA vector is small a vector, and OB vector equal to small b vector, and OC vector equal to small c vector. The position vectors of A, B, C is OA vector equal to small a, OB is small b, and OC is small c vector. The next one, the centroid of the triangle ABC is, that is the centroid of the triangle. Already the position of OG vector equal to the position of OG vector. Centroid of the triangle formula A vector plus B vector plus C vector by 3. That is the centroid of the triangle OG equal to A vector plus B vector plus C vector by 3 is the centroid of the triangle. And position vectors of G is, the position vectors of G is OG vector equal to A vector plus B vector plus C vector by 3. First one, we have to prove the result is area of triangle ABC. First now find area of triangle ABC. First one, now prove area of triangle ABC. Area of triangle ABC equal to, area of triangle ABC is half into 2 adjacent side. Area of triangle ABC is AB into AC. AB vector into AC vector. Area of triangle formula 1 by 2 to adjacent side. AB cross AC, modulus of AB vector cross AC vector. And we can write 1 by 2 modulus of AB vector be a position vectors. AB be a position vector is OB vector minus OA vector. OB vector minus OA vector cross AC vector is OC vector minus OA vector. OC vector minus OA vector is equal 1 by 2 modulus of OB vector is, the position vector OB vector equal to small b vector. B vector minus A vector cross OC vector is C vector. C vector minus small a vector is equal 1 by 2. Now multiply the two vectors. B minus A cross C minus A. First one multiply by B vector in two terms. First one B vector cross C vector. B vector cross C vector. Next one plus and the minus is minus B vector cross A vector. B vector cross A vector. Next one 2 terms over. Next one minus into plus is minus A vector cross C vector. A vector cross C vector. Next one minus in the minus is plus A vector cross A vector. A vector cross A vector. That is equal 1 by 2 modulus of, the first one is B vector cross C vector. B vector cross C vector minus B vector cross A vector minus A vector cross C vector. A vector cross A vector value, the two equal vectors are parallel vectors. The vector product value is 0. That is the value is 0. That is the value is, that is equal to 0. We can write 1 by 2 modulus of B vector plus 1 B vector cross C vector minus B vector cross A vector is, interchanging the vectors, minus B vector cross A vector is A vector cross B vector. A vector by using the property plus A vector cross B vector. Already you know the property A vector cross B vector is not equal to B vector cross A vector. But right here A vector cross B vector is minus of B vector cross A by using the property. Minus B vector cross A vector is A vector cross B vector. Next one minus A vector cross A vector is plus C vector cross A vector. C vector cross A vector. Now write in the order 1 by 2 modulus of, first one is A vector cross B vector plus B vector cross C vector plus C vector cross A vector. That is 1 by 2 modulus of A cross B, B cross C, C cross A is area of triangle ABC. That is, therefore, this one is area of triangle ABC. This is equation number 1. That is equation number 1. Already equation 1 is find out. The next one find out the result area of triangle GAB. Now find the result area of triangle. Next to find area of triangle GAB. Area of triangle GAB. Area of triangle GAB. Area of triangle GAB is 1 by 2 multiply of 2 adjacent side. GA into GB. That is GA into GB. 1 by 2 GA vector cross GB vector. GA vector cross GB vector. Now find the area of triangle GAB equal to 1 by 2 GA vector cross GB vector. This is equal 1 by 2 modulus of GAB be a position vectors. The position vector is OA vector minus OG vector. OA vector minus OG vector cross this one is OB vector minus OG vector. That is equal 1 by 2 modulus of, now multiply two vectors. First one is OA vector cross OB vector. OA vector cross OB vector. Next one, plus and minus is minus OA vector into OG vector. Minus OA vector cross OG vector. And next one, OA into OG. Next one, minus, the plus is minus OG into OB. OG vector into OB vector. Next one, minus into minus is plus OG vector cross OG vector. OG vector cross OG vector. First one, OA cross OB. Next one, minus OA, OG minus OG into OB plus OG vector cross OG vector. OG vector cross OG vector is, two vectors are parallel. This value equal to 0. This value is 0. The remaining vector 1 by 2 modulus of OA cross OB. OA vector cross OB vector is where OA is be a position vectors. OA vector is small a vector. That is small a vector cross B vector. Where OB is small b vector minus OA vector. That is a right in a small a vector into OG vector be a position vectors. OG vector be a position vector, that is a centroid. This centroid is A vector plus B vector plus C vector by 3. OG vector value A vector plus B vector plus C vector by 3 minus OG vector cross OB vector. OG is A vector plus B vector plus C vector by 3 into B vector. Into B vector. This value is 0. This value is 0. It is a modulus. That is equal 1 by 2 modulus A vector cross B vector minus, now multiply of minus A vector this term multiply by A vector minus A vector cross A vector minus A vector cross A vector by 3. And next one, plus and minus is minus A vector cross B vector. A vector cross B vector by 3. Last one, minus into plus is minus A vector cross C vector. A vector cross C vector by 3. And next one, minus of A vector plus B vector plus C vector by 3 cross B vector. This value is multiplied by B vector. That is minus, first one is minus A vector cross B vector by 3. Next one, minus into plus is minus B vector cross B vector. B vector cross B vector by 3. Next one, plus minus into plus is minus C vector cross B vector by 3. Multiply the vectors. That is equal 1 by 2 modulus of A vector cross B vector minus A vector cross A vector. Vector equal vectors values is 0. A vector cross A vector values is, this term is 0. This value is 0. That is equal to 0. Next one, minus A vector cross B vector by 3. Next one, minus A vector cross C vector by 3. This term minus A vector cross B vector by 3. Next one, B vector cross B vector. Equal vectors value is 0. That is the value equal to 0. This value is 0. Next one, minus C vector cross B vector by 3. That is equal 1 by 2. Taking LCM and 3. Now cross multiply 3 times of 3 times of A vector cross B vector minus A cross B. This term minus A cross B. That is minus 2 times of A vector cross B vector. Next one minus A vector cross C vector minus C vector cross B vector, which divide by 3. That is equal 1 by 3, taking outside 1 by 3 into 1 by 2 times of 3 times of A cross B. 3 times of A cross B minus 2 times of A cross B is 1 times of A cross B. A vector cross B vector. The next one minus A vector cross C vector is now interchanging C vector cross A vector plus C vector cross A vector. Next one minus C vector cross B vector is now interchanging plus B vector cross C vector. That is equal 1 by 3 is 1 by 2 A cross B, B cross C cross A is area of triangle ABC. That is the 1 by 3 times of area of triangle ABC. 1 by 3 times of area of triangle ABC. Similarly, we can prove area of triangle GBC equal to area of triangle GCA equal area of triangle 1 by 3 times of area of triangle ABC. Similarly, we can prove area of triangle GBC equal to area of triangle GCA equal to 1 by 3 times of area of triangle ABC. 1 by 3 times of area of triangle ABC. That is equation number 2. Already equation 1 is find out the result is area of triangle is 1 by 2 modulus of A cross B, B cross C, C cross A. That is getting the result. Therefore, from equation 1 and 2 we get that is the result is area of triangle GAB equal to area of triangle GBC equal to area of triangle GCA equal to 1 by 3 times of area of triangle ABC. That is the result is proved. Now discuss a new topic, work done by force. Work done by force. Work done by force. The one of the particle A is the one of the particle. One of the particle acting on one force, that is a effect will be a force. One of the particle acting at a force A, the one of the particle is displaced from the point is B. That is a displaced. That is a displacement is AB vector. That is a displacement is D vector. The total work done by force is total work done by force W equal to F vector dot D vector. F vector dot D vector is the total work done by force W equal to F vector dot D vector, where F is the force. F is the force and D vector is the displacement. That is the displacement is one of the particle A from the point from B to the point is B. That is a displacement is AB. That is AB vector equal to, that is D vector is AB vector equal to, let AB vector be a position vectors. AB vector is, now we can write in the position vector is OB vector minus OA vector. OB minus OA vector. That is AB vector is OB minus OA vector equal to, that is a displacement D vector. Now find the D vector is OB minus OA is the D vector by work done by force is total work done is W equal to F vector dot D vector. F is a force, D is the displacement. One point to another point, that is a displacement is a D vector. That is a work done by force by using exercise problem. In exercise problem 11th question, a particle acted on by constant forces 8i plus 2j vector minus 6k vector and 6i plus 2j minus 2k vector is displaced from the point 1, 2, 3 to the point 5, 4, 1. Find the total work done by forces. What is given? Given the constant forces are two vectors 8i plus 2j minus 6k and 6i plus 2j minus 2k is constant forces. Given the forces, constant forces, the first one is F1 vector. This is a F1 vector. First one force is 8i vector plus 2j vector minus 6k vector. F1 first one force is 8i plus 2j minus 6k and the second force is F2 equal to 6i plus 2j minus 2k vector is, that is the force F2. We want the total resultant forces, that is the resultant forces, that is F vector equal to F1 vector plus F2 vector. That is the resultant forces F vector equal to F1 plus F2. Add the two forces. 8 plus 6, 14i vector. 14i vector. 2 plus 2 plus 4j vector. Minus 6 minus 2 is minus 8k vector. That is the resultant force is, one of the force is 14i vector plus 4j vector minus 8k vector is the force. Now find the displacement. Find the d vector. D vector, one of the point is displaced from the point 1, 2, 3 to the point 5, 4, 1. Given the first point is OA and the second point is OB vector. That is the point is, the first one point OA vector equal to 1, 2, 3 is, now change in the vectors, I vector, 1 and I vector is I vector plus 2j vector plus 3 vector, 3k vector, that is the point is OA vector. And the displacement from the point B is 5, 4, 1, that is the position vector OB vector equal to 5, 4, 1 is 5i vector plus 4j vector plus 1k vector is k vector. The point is 1, 2, 3 is right in there. Vector is I vector plus 2j plus 3k. And the point, second point B is 5i plus 4j plus k vector. Now find the displacement d vector equal to, d vector is OB vector minus OA vector. OB minus OA is the displacement. It is OB minus OA. Subtract two vectors. 5i minus I is 4i vector. 4i vector. Next one. 4 minus 2 is plus 2j vector. Next one. Okay, 1 minus 3. 1 minus 3 is minus 2. Minus 2k vector. That is a d vector. This d vector is 4i vector plus 2j vector minus 2k vector. Now find the total work done by force. Already you know work done by force is W equal to F vector dot d vector. That is the work done by force W equal to F vector dot d vector. Now find the total force is, now total work done by force W equal to F vector dot d vector. That is the work done equal to F vector dot d vector. Total work done. That is the F vector is 14i vector. 14i vector plus 4j vector. 4j vector minus 8k vector. Dot d vector is 4i vector. 4i vector plus 2j vector minus 2k vector. Minus 2k vector. Now multiplication of two vectors. Multiply is dot product. That is a dot product. Work done by force is a scalar product. That is a dot product. Dot product already you know I vector dot I vector values is 1. Otherwise I vector dot j vector values is 0. Now first one multiply 14 into 4. 14 into 4. 14 into 4. 4, 4, 16. Remaining 1, 4, 1, 4, 56. 14 into 4, 56. Next one 4 into 2. 4 2s are 8 plus 8. Minus into minus is plus. Plus 8 2s are 16. 8 2s are 16. Now add the value. 56, 64, 64 plus 6, 70, 80. 56 plus 8, 64. 16, add the value 16. 6, 4, 10, remaining 1, 7 on 80. That is the result is 80 units. Therefore, the total work done equal to 80 units.